Okay, hello everyone. So let's get started with lesson 2. Hang on a second. Okay. Just loading it. Okay. So we talked a bit about last class. Psychology is very often unintuitive, right? Stuff you'd think would be pretty straightforward. What you'd expect are often not the way people think or behave. So, short answer, no. We can't just think our way through psychology. It's not just common sense. We need the scientific method. And if you remember from last class, we talked about 3 particular biases that can make it seem like we can only use intuition to understand psychology. That was hindsight bias. Remember this idea that once you know something, it seems really obvious that you could have predicted it or could have known it, right? Overconfidence in general, so just not being able to kind of realistically estimate, confidence in things and how accurate we actually are. And of course, the biggest one, the tendency to perceive patterns in random events, right? So thinking that maybe, the Broncos won because I wore this t-shirt or these socks, when really it was a coincidence that happened like once or twice. Okay. So like we said, in order to see if an idea really holds true, we need to test it rather than intuit it. That's actually a word. Remember, psychology is based on empirical evidence using the scientific method. Okay. Just as a little primer, little activity here. Read this, I'll read it to you, and tell me what you think might be the problem here, or problems. A researcher wants to know what the best way to study for a test is. Ask people what they think is the best way to study for exams. The most common answer is rereading the chapter. He concludes that rereading the chapter is the best way to study. What's the problem here? Think about it for a second. Well, the biggest problem is that, again, if you rely on intuition, who knows what's accurate and what's not accurate, right? And there's actually a lot of research on this. Our own Dr. Matt Rhodes, professor here, he's actually, one of the studies he's most well known for was demonstrating how people often pick the wrong strategies, essentially. They think that ways that are not good ways to study are actually good ways to study, in ways that, sorry, I forgot what I just said, but ways that they mix up what's a good way to study and what's not a good way to study, and they often pick the wrong strategy when it comes to studying. So problem here is that we don't really know and that goes on the side of the researcher and of the participants. We don't actually know what people think is the best way to study. Is that the actual best way to study? That's, again, where this idea of empirical science comes into play. So, if you remember from last class, talked about the scientific method as kind of a general procedure you follow. The first being you ask a question, what is the best way to study? Or maybe does making things distinct, does that help us remember them? Are people more likely to conform to others in social situations? Right? What part of the brain does X? Whatever it might be, start with your question. Then comes the hard part, right? Questions are only the beginning, and the next part is to actually make a hypothesis, which is, remember this, a testable prediction, often implied by a theory. So if you have a good theory or a good reason why making things more distinct might improve your memory, well, okay, let's put that to the test. Let's make that into an actual hypothesis. Maybe one group of people gets to study distinct words or pictures or faces or whatever, The other group gets to study less distinct ones, and we compare performance remembering those things, right? The hypothesis would be that the more distinct stuff will be remembered better. And then, of course, you test that hypothesis, which we'll get to next, analyze your data, and report the findings. That's another thing too. A lot of psych, well, I wouldn't say a lot, but a decent amount of psych, at least psych research, is actually stats. So sorry to disappoint you if you don't really like stats, math. It's not really, and we're not gonna cover it in this course, but I'm just saying, as you take more courses in psych, you do have to do some stats. And there's quite a range. Some of the more, clinical counseling and social sometimes they need to do some pretty fancy stuff. Cognitive is generally a little bit easier. You kind of just comparing conditions to see if they're significantly different or not. But like I said, you don't have to worry about that in this class at least. Okay, another big thing. So remember that a big part of science too is to remain objective. Not always as easy as it sounds, but thinking of that, what is the problem with this research? A researcher wants to know if watching violent movies increases aggressive behavior. The researcher has two groups watch movies. So one watches a violent movie, the other one watches a comedy. The researcher follows them around, watching for aggressive behavior to compare the two groups. There's a few problems here, but what's kind of the big one? For a second. Well, biggest thing here is that what the heck do we mean by aggressive behavior, right? What does that even mean? How do you know, is it number of people murdered, number of aggressive driving maneuvers, fights started? What is it, right? So that's the other big part that we always want to keep in mind, right? We need objective measures. We need to find a way to quantify something in a reliable and unbiased way. So the issue here is that, okay, maybe I just, because I want my experiment to work, or this person wants their experiment to work, maybe not even consciously, they are more lenient about calling things aggressive behavior when it's in the condition they want to be aggressive, right? So that's always another thing to keep in mind. And this kind of brings me to the next point, the idea of confirmation bias. So confirmation bias is just in my opinion, I think maybe the most important psychological finding ever. It just comes up everywhere if you think about it. It's not even something I've ever done research on, but it's so common. Confirmation bias is the finding that people will very likely, believe things that are or kind of interpret things in a way that's consistent with what they already believe, right? I try to give you a little bit of a break, by the way, just if you're taking notes, but I won't do too much because if you can just pause it if you need to. If this were in person, it'd take much longer breaks. Anyways, so confirmation bias, like I said, can be a big issue in many domains, but could certainly pop up in research. So with the prior example, confirmation bias come into play here, right? Well, let me back up though. So confirmation bias again is just interpreting things. You've probably heard of this before in a way consistent with what you believe or what you want. So I am a big Broncos fan. Watching a game, there's a close call. Obviously, I'm going to, interpret it as, or there's a close play. I'm going to interpret it as going the way I want it to. The Broncos didn't commit a penalty, got the first down, whatever it might be. So that's something else to think about in terms of our research, right? In the prior example, you need to be very clear about what is an aggressive behavior. You can't leave it open to interpretation because the researcher could be showing confirmation bias and kind of interpreting things in a way that they want to. They're going to interpret maybe less aggressive behavior as aggressive behavior in the condition they want to see show aggressive behavior. So this is where, like I said, operational definitions comes in. Operational definitions are basically how you're going to quantify something, right? So much better, I mean, well, still pretty bad, but better way of quantifying aggression might be, again, number of aggressive drive. Well, that's still not great, but let's say number of fights started. I mean, it's at least a little more clear there, right? If I was interested in memory, it's going to be, okay, number of words correctly recognized on a test, number of correct multiple choice answers on a test, something like that, right? Something objective, some numerical measurement of whatever it is I'm trying to measure. Okay? So that's important. Another big thing when it comes to science and psychological science is replication. Okay? So what we mean by replication is just that someone else, can they show the same findings you can, right? And this helps, having objective measures, having clear procedures makes this a whole lot better, right? So if we're dealing with something that's totally open to interpretation, like violent behavior, might be hard to replicate that because it's very open to interpretation, like we said. Something like number of correct answers on a test, that's a lot better. But anyways, replication is very important in any science because it helps us figure out what's true and what's not true, right? So if we go back to the example from first lecture on classical music being good for infants, well, we need to replicate that, right? We need to show it consistently, not just in one study, to accept it as, as a real thing. When nothing replicates, we don't really know what's true or what's false. Okay. So how about that? On to actual more specific methods of doing research. So one big one, well, is just simple descriptive research, right? This is when you're not so much manipulating anything, you're just observing and describing behavior, right? So you can ask slightly more straightforward questions like, what is the average age people move out? How often do they go shopping? And are these related to some other factors? Maybe number of times you go shopping depends on your age, something like that, right? Kind of moving into a little more detail here, there's kind of more subdivisions of descriptive research. Case studies are in-depth investigations of a person or group, right? And ideally, we want these results to be generalizable, but they're not always generalizable. So when might someone do a case study? Just think about that for a second. When might we pick a single person or a small group of people to do a study on? Well, usually when it's kind of a rare or unusual condition, and also when there's ethical considerations. So for example, something that's often looked at with case studies is certain types of brain damage, right? There was a really famous case, I think he passed away now a few years ago or something, but of someone who basically had a certain brain surgery that went wrong, and he had no long-term memory, so we could only remember things that happened like 30 seconds ago. So obviously that's something ethically and that we can't really do for ourselves, right? We can't go and mess up someone's brain permanently just to study them. It's also kind of a rare and unusual condition, but it's told us a lot about distinctions between short and long-term memory. right? So with that, think about what are kind of some of the pros and what are some of the cons of case studies. Think about that for a second. Well, the pros are you can kind of get pretty in-depth research into, something unusual or something not common, right? The cons are kind of like we already talked about. The cons are that you don't know if these results are generalizable, like we said, to other people, right? So with the example of the person with no long-term memory, I mean, it did help illustrate that there's kind of seems to be a distinction between short and long-term memory, but we don't know exactly how this might exactly apply with people without that specific brain damage, right? I mean, maybe that brain damage did something really unique, and in reality, there is no distinction between short and long-term memory, just as an example. So, and you often have very few people, like I said, very few people, even a single person. So you can't tell if that's going to generalize. Okay. Another one, just in terms of descriptive research, is what we call naturalistic observation. So what you're doing here, as the name implies, is you're just really watching people. It doesn't necessarily have to be people, but watching something occur in its natural environment, right? And the key here is that you're not really intervening in any way. You're not getting involved. You're trying to keep things as realistic as possible. So for example, maybe I want to look at how do students spend their breaks, right? Like say I give a 10-minute break. If it's a really long lecture, I give them 10 minutes to go get coffee or go to the bathroom or whatever they want to do. I might just sit at the front of the class if we're doing this in person and watch people. Where do they go? What do they do with their time, with their 10-minute break? That would be something like naturalistic observation. Maybe in contrast or similar, I just want to see how many people use a particular facility at CSU. So maybe I just go and sit on a bench outside. No one knows I'm doing research, and I just count the number of people that go inside that building in a given week. Right? Again, very unobtrusive. You're not getting involved in any way. No one even knows you're there doing research. You're able to see things as they occur naturally. And again, a key here is that we want to be able to code behaviors in a clear and objective way. So again, with operational definitions, we want to make sure we're clearly defining what it is we're measuring. Number of people that come in and out of the building, that's good. Number of something else that's really not clearly defined, that's obviously a problem. Just on that note, there's another kind of related idea that you'll often do, something called inter-rater reliability. So let me give you an example of this. I'll go back to the aggressive behaviors idea, just because it's easy to kind of demonstrate bad research from it. Let's say I have two different people watch for aggressive behavior, and they watch the same, say we record it, and they both watch the same video clip. One counts 10 instances of aggressive behavior, one researcher. The other researcher counts 2 instances of aggressive behavior. What does that say about kind of the reliability of the measure of the measure of aggressive behavior? Well, nothing good, right? It's saying that it's, again, totally open to interpretation. This is what we mean by inter-relater reliability, is if we have two people and they're watching the same thing, are there measurements about the same, right? So in contrast, let's say I looked at the score on a memory test or a multiple choice test. If one researcher thinks you got 8 out of 10 and the other researcher thinks you got 8 out of 10 as well, that suggests that there is high inter-rater reliability. Basically, it's not open to interpretation. Both the researchers are seeing the same thing in terms of the measurement. So that's another thing, and we can. This is something we can test for. There's a statistical analysis measuring inter-rater reliability that you'll often do. So with that in mind, what are kind of the pros and cons of naturalistic observation? Just let you think about that for a second. Well, the great thing is, as you could kind of expect, is that you kind of avoiding stuff like people knowing you're watching them, ideally, right? So let's say I wanted to know how often people use, something that maybe they would be embarrassed about. Naturalistic observation could be good there because I'm kind of less likely to have to worry about them being dishonest if I just ask them, right? Maybe, for example, I wanted to know how many times people cheat on exams. And I mean, hopefully never, but say I sat at the back of the class and pretended I was a student, and I counted the number of people I saw cheating, right? This might be a better way to get an estimate of that rather than asking people, how many times did you cheat on your exams, right? Because who knows if they're going to be honest or not. So that's kind of the pro of naturalistic observation. Again, you can see things without people knowing you're doing research necessarily and kind of get unbiased measurements of whatever it is you're interested in studying. The downside of naturalistic observation is there's just a lot of things you can't really look at through using this method, right? So if I'm interested in memory, pretty tough to see how people are remembering things just by watching them do I don't know what, right? Like, I don't know how you would look at memory using some sort of naturalistic observation, right? If I'm interested in, does smoking correlate with cancer? Well, it's pretty tough to just, without following them around 24/7, get a sense of how often people actually smoke and if they have lung cancer or not. So the bottom line is there's a lot of things you can't just practically look at using this method. So that's kind of the con. Okay, the other one, last type of descriptive research are surveys. Basically what you do here is, as you probably are aware, you're just sending out some sort of questionnaire. It could be through mail, could be online, could be distributed through classes, whatever it might be, kind of asking people about whatever, their opinion, their experiences, something along those lines, right? And you usually get a lot of data here, but it's usually less in-depth. Like I said, people are going to respond to questions about their experiences. Well, what's kind of the advantage of a survey? Well, the nice thing about a survey is that you can get a lot of data. They're cheap to do. They're easy to do. You send out a survey online, you can easily get 1,000 responses. It's a good way to collect data. What are some issues that might arise with using surveys? Well, you do run into some methodological issues with surveys. Kind of unlike naturalistic observation, I kind of alluded to earlier, is you can run into the idea of social desirability. So people might respond in the way that they think you want them to. They might even just kind of generally be dishonest with themselves, right? So if I, again, if like the example I gave earlier, if I ask you, how often do you cheat on your exams? And let's say, I'm sure you don't do this, but say I asked a person, how often do you cheat on your exams? And they do actually cheat on their exams. Would they be honest? Tough to say. They probably want to look good to the experimenter or the researcher. They also maybe don't want to admit it. That's kind of what we mean by social desirability. So you don't always get 100% truthful answers. Another thing to always be concerned about with surveys is how you phrase the question or how you word it, basically. And luckily enough, I don't have to really do surveys. I just do experiments in psych, but you do run into the issue sometimes of how you phrase a question can really alter people's responses. So for example, there's some research showing that phrasing something as do you support, say, gun control versus do you support gun safety can actually produce different responses, even if it means the same thing. Right? If you were to ask people, would you be opposed to or would you be okay with a 40% tax rate for welfare versus you tell them, would you be okay with a 40% tax rate for, I forget the exact words, those in need or something like that. You actually get very different responses there just based on a few subtle changes of words, even though they mean the same thing, right? So that's something you always have to be aware of with surveys, that how you phrase the question can actually really change the results. Okay. Another thing to always keep in mind when you're doing surveys is how representative is the sample of the actual population. So what we mean by sample is just the people you interview or just the people you collect data from. The population is everyone you're interested in applying that data to, right? So if I ask a question about, let's say, opinions on anything, right? Opinions on food. The population there is basically what could be, say, the whole US, whereas maybe the sample I use is just, well, it implies a sample of people I got to represent that population, because I'm not going to interview every single person in the whole country, right? But it's important to think about how the sample is going to be representative, especially when you're dealing with something that could change a lot, by demographics. So, or by who you're asking, basically. So for example, if I asked a question about, say, gun control, I could get very different answers from people living in California than people living in Texas, right? So that's something to be aware of. And again, if the sample here, let's say I'm interested in applying this to basically all of the US, I'm looking for what's the general opinion in the US on this issue. Well, if I only interview people from one of those two states, it's not really representative of the whole population being the whole country, right? So that's another thing to worry about. And you can run into something called selection bias, where your sample is not representative of the population, right? So this is something where, again, maybe your methods in some way kind of attract certain participants that could not be representative. So let me just give you an example of that. Say I was concerned with some issue that could be very different, or people could have very different opinions on based on age. So maybe younger versus older people have a very different opinion on a certain issue. But I run the survey over the internet. Well, maybe more young people are likely to respond if I collect data on the internet rather than, say, through phone. That might be an example of selection bias. Because again, just the method I chose is more likely to attract young people than older people. Really, younger people have very different opinions than older people, and I want my sample to be representative, right? And there are some ways we can account for this using different sampling methods. But this is kind of where, again, this all centers on the idea of generalizability. So does whatever data I collected, is that generalizable to most people, right? So I collect data on some issue only from a college campus. Well, that's probably not generalizable, to the whole country. Maybe it's other people and other professions have very different opinions on this, right? So like I said, there's a few ways around this. One method that isn't really a way around it though is just using convenience sampling, meaning you're basically going to use whoever's willing to do your survey. So maybe I just put it out on the internet, I put it on SurveyMonkey or whatever it is. Oftentimes when we run experiments, we just use CSU students, first year CSU students. This obviously has a nice convenience factor, but the problem is of course, again, it might not be representative. But again, you can kind of think critically about this where how representative it needs to be depends on the issue, right? If I'm looking at something like, say, recognition memory, which is what I look at, I mean, as far as I know, recognition memory doesn't differ by, well, a little bit by age, but not by state, not by education level, not gender, stuff like that, right? So that's, you know, something like that. Maybe I would use a convenience sample because there's not really any reason to expect it's going to differ by various factors like that. On the other hand, if I am looking at something that could differ, then that's something I need to be aware of. Okay, another one, a way to actually account for sampling biases and non-representative samples is to use what we call simple random sampling. So this might be something like you have a random dialer and you just dial random numbers and ask people to participate in your survey, right? So if I'm going to do this, it's kind of expected that if I can get a good sample size, it's going to be representative of the population. So, for example, if I call 10 people, maybe by bad luck, I get almost all of them are older or almost all of them are younger. If I call 1,000 people or 100 people, it's generally going to be pretty representative just through what we call the law of large numbers. I'm going to get a decent split, a decent amount of young and older people, which is what I want. But another idea is just to use what we call stratified random sampling. So what you're doing here is you're matching proportions of subgroups in the sample to proportions in the population. So what I might do is call people at random, but only stop when I have a certain percentage of boys, certain percent of girls, a certain percent of older, a certain percent of younger, something like that. So then I know it's going to be representative of your population I'm interested in. Okay. A little review here. So Dr. B decides he can best study children by going to a preschool and seeing what the children there do in a typical day. This is an example of a study, naturalistic observation, a survey, correlation, or experimentation. Well, this is going to be naturalistic observation because again, you're not really doing anything other than watching. It's not a small group that or particular individual that you're studying, and you're not giving out a survey. Okay. Next one is correlational research. So this is really just looking at, you can actually do more than two variables, but we'll just go with the simplified version. How strongly are two variables related to each other? You can have a positive correlation and you can have a negative correlation. And what a positive correlation means is that as one variable increases, the other one tends to increase as well. So an example of that might be shoe size and height. Typically people who are taller also need bigger shoes, right? That would be an example of a positive correlation. As one variable, shoe size, goes up, height tends to be higher as well, right? But also keep in mind that as shoe size goes down, height will also go down. So the key here with a positive correlation is that the two variables tend to move in the same direction. A negative correlation is when, well, it's the same idea, except that two variables go in opposite directions. So an example of that might be number of arguments in a relationship and relationship happiness, right? So more arguments, the more times you fight with your partner, the less happy you're going to be with your relationship. So we're going in opposite directions this time. And conversely, the less fights you have in your relationship, the happier you're going to be in your relationship, right? So we're going in opposite directions. Okay. You don't have to know all the stats behind it, I think, but the correlation coefficient is basically what is used to measure the strength of this relationship, and it can range from -1 to +1. It can also be 0. So a +1 correlation means that there's a perfect relationship. So basically what that means is I can predict all of the change in, say, height. I can predict from person's shoe size. I can perfectly predict one of those variables from the other, right? This, of course, never actually happens in reality. Right? In reality, we never get perfect correlations because it's always, I think if you get like a 0.3 correlation, that's really good. Anyways, a -1 correlation means the opposite, well, means the same thing, but in the other direction. So again, say we're looking at number of fights and relationship happiness. If I can perfectly predict the number of, or how happy you are with your relationship based on the number of arguments, then it would be a -1 correlation. And basically the way it works, or sorry, let me come back to this, but 0, of course, means that there's no correlation. Anything in between indicates basically how strong the correlation is. So I have, say, a 0.75 positive correlation. I'm predicting a very good amount of one variable from another. If I have a -0.75, I'm doing the same thing. It's just they go in the opposite directions. If I have, say, 0.05 correlation, that means there's a very small relationship between two variables. Right? So I can predict a very small amount of relationship happiness from number of fights. Okay. Let's see. So the pros and think about what might be the pros of correlation research. Well, one nice thing is that you can kind of look at some things that you can't look at through experiments. And I'll come back to that. But what is kind of the big con of correlation that you might have heard before? What does correlation not tell us? Well, it doesn't tell us anything about actual causality. So hang on, I'll come back to those examples. Correlations don't tell us really that one variable causes another. So for example, if I buy you bigger shoes, that's not going to make you taller, right? Unless they have lifts in them. Lots of stuff like that, right? It doesn't mean that one variable is causing another. So back to the old example, if I look at, say, in a correlational study, the number of violent movies you like to watch and your measure of aggression, however I measure that, well, we don't know if there's any causation there, right? It could be that it could be that, watching violent movies makes you more aggressive, or it could be that maybe because you're a more aggressive person, you like more violent movies. I don't know. But so there's kind of the issue of directionality. It's not clear what is causing what, but there's also another issue. And that's of the third variable problem. So let me just give you a couple examples. There's a pretty strong correlation between the amount of cheese consumption per capita and number of people who died becoming tangled in their bed sheets. No idea why. Becoming a pirate, number of pirates and global average temperature. Real cause of autism and organic food sales. I think organic foods are really tough, so whatever. Number of films Nicolas Cage appeared in, and number of people who drowned by falling into a pool, which makes no sense because Nicolas Cage is obviously the greatest actor of all time. This is, so like I said, we don't know, does X cause Y, does Y cause X, or maybe there's even no causation there, right? Maybe Z is actually responsible for what looks like a relationship between X and Y. For example, there's a strong positive correlation between ice cream sales and murder rate. Doesn't make any sense, right? Well, maybe when it gets warmer, more people go outside, and that results in a higher murder rate. And also, when there are more people outside and it's hot, more people buy ice cream, right? So there's a third variable making it look like those two are correlated, and they're actually not. Just to go back to the other example of movies, violent movies, and aggression. Well, maybe another issue is just that a person's parents are not that good, and they let them watch violent movies as a kid, and you know that they also didn't teach them to be not aggressive all the time. So maybe that's the third variable there, just as an example. I don't actually subscribe to any of that research, but it's not my field, so I don't know. Anyways, takeaway, be very critical of correlations, right? Be cautious about, actually really just don't at all say that one variable causes the other. It's possible, but you're very likely going to get dig marks if you say that correlation is causation. So just say one variable predicts another. Not that one variable is causing another. But just on that subject, keep in mind that sometimes prediction is what you want, right? So for example, if you apply to grad school, you have to take something called the graduate record exam. And it's kind of like, do they still do the SATs? Well, it's kind of like that, right? But for grad students, it's kind of like an IQ test. And you know, the hope would be that would predict your success in grad school. So if someone does well on the GRE, they're going to do well in grad school, and if they do badly, then they're not. And that way you can kind of predict which students you want to take and which you don't. So sometimes prediction is all you want there, right? It's not that the GRE causes you to do better. It's just that your skill and intelligence causes you to do better, but the GRE is kind of a measure of that, and we could use that as a predictive tool. So sometimes that's all you want. Okay, what is a little review? What is this image on the left an example of? Description, positive correlation, negative correlation, or your Friday night. Well, this would be a negative correlation, right? Because as one variable increases, number of beers drank, your grade declines, right? So you can kind of see the trend there. You see the association. One variable increases, the other decreases. They go in opposite directions. In contrast, let's say it started in, you see my mouse? Bottom left corner, it goes up to the top right. That would be a positive correlation because beers drank goes up, grades also go up. That would be a positive correlation. But here it's negative. That would be great, wouldn't it? Okay. Last major method is that of actual experimentation. Right? This is when researchers actually manipulate a variable to study its effect on behavior or mental processes. So the core of any experimental design is that you're going to have two variables. One is called the independent variable, one is called the dependent variable. Make sure you remember these. So the independent variable is basically the variable that we change. And we change it to see if it has an effect on the dependent variable. Okay, let me just say that again. The independent variable is the thing you manipulate. The dependent variable is the thing that you measure. You want to see that your independent change in the independent variable has an effect on your dependent variable. So for example, let's say I wanted to look at the effect of coffee on exam performance. These people are not doing very well. What I would do is I'd randomly assign people, we'll get to that next, to two conditions. One condition One group of people gets 4 cups of coffee, the other gets 0 cups of coffee. I then take what I do is I take the average score for each condition. So on average, people who got 4 cups of coffee get about 45%. Those who got 0 cups of coffee get only 15%, right? That's what we're talking about with experimentation. So randomly assigning people, and they each get a different treatment. So here the independent variable is whether they get coffee or not. The dependent variable over here is performance on the exam. What you'll typically do is compare the experimental group to a control group. A key assumption here is that everything is going to be the same except for the independent variable. So in this example, experimental group gets 4 cups of coffee. They get some sort of treatment. The control condition gets 0 cups of coffee. They're the control group. But something you always need to be very cautious of in experimental design is that we want to avoid what's called a confounding variable. A confounding variable is anything that could basically vary along with your independent variable that you don't want to. So that might have been confusing. Let me give you an example. Let's say I'm looking at this same thing of the effect of coffee on exam performance. What if I test one group at night and one group early in the morning? That would be a confound because now something else is being changed along with my independent variable. It's not, now we no longer know, is it the effect of coffee or is it the effect of time of day, right? If one group is being tested in the morning, one group is being tested at night, that could have an effect, right? Now we don't know, like I said, is it the coffee or is it the time of day? So that's something to always be aware of, confounds, right? Something that could be causing an effect that you're not intending to manipulate besides your independent variable. So a big thing when it comes to experimental designs also is using random assignment, right? What we mean by random assignment is that you're gonna well, as the name implies, randomly assign people to conditions. So for example, on this be easier if we're in person, but if I number you off 1, 2, 1, 2, 1, 2, all the ones get coffee and all the twos get no coffee. That would be random assignment. In contrast, let's say I split up people and I put the people who normally sit towards the back in the no cups of coffee versus people in the front go get the coffee. That would be a confound because then I'm no longer randomly assigning people to conditions. And then you have a confound again because now maybe it's something to do with that people who sit at the back or the front are good or not as good at taking the test. Maybe it's not the coffee anymore. But when we randomly assign people conditions, I don't have to worry about this. Because any difference, right, between, let's say, test performance is going to be about equal across the two conditions. So say, obviously, some people are just going to do better on the exam than others, but that's okay because I'm randomly assigning people. I don't have to worry about that as a compound because the good test takers and the bad test takers and the people responsive to coffee or not are going to be equal across the two conditions. So that's a key there. Okay. Just one last example. Does vitamin C improve mood? What I would do here, randomly assign people. One group gets vitamin C, the other group gets nothing. And then I'm going to ask about mood on a scale from 0 to 10. 10 is the best, so as you're in the best mood ever. Independent variable here is whether they get vitamin C or not. Dependent variable is going to be mood report, right? But what might be an issue here? It begins with a P, if you've ever heard of it, with this particular experiment. Well, we have to protect against something called the placebo effect. You may have heard of this before. It's pretty cool, actually, I'd say. This is the idea that basically just expectations could alter your results. on the part of the subject. So if I tell both conditions, if one condition knows they're taking something that they think could help their mood, and one group is getting nothing, this is a problem because we don't know if there's a placebo effect going on in a group that's getting vitamin C, right? It could be the case, and there's a lot of studies showing, there's millions of studies showing this, I'm sure. I mean, not millions, but quite a few studies showing that the existence of placebo effects in a lot of different domains. So just the expectation of, hey, I'm getting something that the researchers think will help me can bias people. They might actually just, again, this is the placebo effect, think that it's going to help them, and that can alter the response. While the other group is getting nothing that they think could help them, right, or improve their mood. So that's what placebo effects are. And a way around this is that the subjects don't actually get to know what condition they're in. So what I would do is rather than give the control condition nothing, I would give them a fake pill. I'd tell them, hey, I'd tell both groups there's vitamin C in this pill, but only one group actually gets a pill with vitamin C in it. The other one gets an empty pill or a sugar pill or whatever. That's how you can account for placebo effects. Because what you're expecting there is that people who get the vitamin C, if their different mood goes even beyond that of placebo group, then we know that it's due to the actual vitamin C. It's not just a placebo effect. Okay. But this doesn't necessarily guard us from all types of bias, because it doesn't guard us from bias of the researcher, right? So obviously the expectation on the part of the subject could be an issue, but expectation on the part of the researcher could also be an issue, right? So let's get an example here. Well, okay, we'll use the same example. If I really do think that coffee is going to help with your exam performance, that could be an issue for me, right? Because if I know which people got coffee and which didn't, I could be biased in my grading, right? If I'm expecting that people who got 4 cups of coffee are going to do better on the exam, I could maybe even unconsciously grade people who I know got coffee more easily, right? Because I'm expecting them to do well. So that's another thing to keep in mind, is researchers' biases could also be an issue. And there's a way around that as well, called the double-blind procedure. In this procedure, neither subjects, that's what we mean by SSS, experimenters and subjects don't know what condition they're in. So in this example of vitamin C, I'd obviously give one group placebo, one group gets actual vitamin C, and they would taste the same and look the same. Just because it's a funny side note or an interesting side note, worse tasting pills actually produce bigger placebo effects. Cool stuff. But also, the researcher doesn't know what condition you're in. So if I was doing the exam one again, it'd be best to keep it unknown to me which exam takers, which exams were taken by people who got coffee and which didn't, so that my own bias as the researcher can't come into play. Okay. This is kind of the ideal way to do experiments, right? This is the gold standard. You're kind of defending against placebo effects and bias from the researcher. Okay. Something to keep in mind with experiments in contrast to correlations is that it's the only way to demonstrate actual causality. So when you're doing an experiment, you know that, well, if you do it properly, everything is the same except for your manipulation. So with this example of, vitamin C, I know it's vitamin C causing the difference. There's no third variable problem because I only manipulated I manipulated the one variable, so I know nothing else is changing, right? So with experiments, you know that one variable is actually causing a change in the other because you manipulated it. But also keep in mind that, like all the other methods of research, experiments have downfalls as well. Not everything can be manipulated, right? If I was interested in something like the effect of child abuse, or the effect of teen drinking, or even smoking, those are things I can't really experiment on. You can do smoking with monkeys, I think, but not with people, right? So that's something we need to keep in mind as well, is not everything can be manipulated and experimented with. And that's where correlations have their advantages, right? If there's something like child abuse or teen drinking, I can still look at that as a correlation. I don't know if there's any causation there, but at least I can still look if there's an association, when I can't look at that at all with an experiment because it's not ethical. Okay. So here's another example as a review. If I give half of the class a magic study pill and the other half a sugar pill, that I will give it away, then give everyone a 10-question quiz to see how well you remember content from Module 3. What is the dependent variable in my experiment? Which kind of pill you took, the magic study pill, the sugar pill, your performance on the quiz, how much coffee you had this morning. Well, the dependent variable, I'll let you think about it, is going to be performance on the quiz. Let's actually go through all of these. So which pill you took, that's going to be the independent variable. So if I want to see, does the pill have an effect, that's the thing I'm manipulating, which kind of pill you got, the sugar or the magic study pill. Performance on the quiz is what I'm seeing. Does that improve relative to control based on me manipulating the independent variable? Okay, how much coffee you had this morning is irrelevant. Okay, so just keep in mind as a closing note, there are many different ways to conduct research. Each has its pros and cons. Descriptive research does not explain behavior, it just describes it. Correlation does not equal causation, never forget that. It just simply shows that there's a relationship, positive or negative, between variables. Experimentation is benefits from a large amount of control. You can avoid confounds, and it's the only way to demonstrate causality. Not everything can be experimented on. Okay, that's it for today. I will see you next time.